let us prove that root 2 root 2 is an irrational number. How do we prove that root 2 is an irrational number? Okay. So first of all, you need to know what is a rational number and what is an irrational number. So let us see what is a rational number. What is a rational number? A number which can be written in the form of p upon q, where p and q are integers. P and q are integers, both are integers, and q is not equal to 0. A number which is of the form p upon q, where p is an integer, q is an integer, and q is not equal to 0, is a rational number, right? And a real number which is not a rational number, a real number which is not a rational number, is an irrational number, right? Okay. Now observe this thing. If you have a rational number, for example, you have this rational number 3 upon 15. This is a rational number. 3 is an integer, 15 is an integer, and 15 is not equal to 0. So 3 upon 15 is a rational number, and you can see that I can write 3 is equal to 3 into 1, and I can write 15 is equal to 3 into 5. So this is nothing but, and I can cancel the common factor, which is 3. This is 1 upon 5. So I can write this rational number 3 upon 15 as 1 upon 5, and similarly some other rational number, for example 16 upon 32. I can write this rational number as 16 into 1 upon 32 into 1, which is nothing, 16 into 2, denominator I'll write it like this. I just want to have a common factor, and I'll cancel that common factor. This is nothing but 1 upon 2, and many more. Right, so it means, and now you can see that what is the common factor between, what is the greatest common factor between 1 and 5? Nothing. There is 1. Therefore GCD of 1 and 5 is 1, and GCD of 1 and 2 is again 1. So you can always write a rational number in the form of p upon q, where GCD of p and q is 1. This is called the standard form of that rational number. So here we have the thing that a rational number can always be written as, be written in the form p upon q, where p and q have GCD equal to 1, right? This thing is important. We are going to use this thing when we write a rational number. Okay, now the aim, our aim is to prove that root 2 is an irrational number. So what I will do is, I'll assume that, suppose if possible, that root 2 is in fact a rational number, is a rational number, right? Now having assumed that root 2 is a rational number, I can use the above said definition. I can write root 2 is equal to p upon q, where GCD of p and q is 1, right? Now because q is not equal to 0, so I can multiply this equation with q on both sides to get root 2q is equal to p, and now I can square this equation, square both sides of the equation. So I'll get root 2q square is equal to p square, which says 2q square is equal to p square, right? This is, I'll call this thing 1, this is 2. Now p square is equal to 2q square. It means that p square is an even number, because p square is equal to 2 into something. 2 into something is always an even number, is an even number. So it means that p square is an even number. Now you must be knowing this thing, that the product of two odd numbers is always an odd number. product of two odd numbers is always an odd number. So if you are saying that p square is an even number, so it means that p has to be an even number, because if p is odd, then p into p will be odd, that is p square will be odd. So this says that p is an even number, right? Now if p is an even number, I'll write it down here. P is an even number, so it means that I can write p is equal to 2 into something, say a number 2 into some integer, say lambda, right? So if p is equal to 2 lambda, put this thing in 2, you'll get 2q square is equal to 2 lambda square, which says 2q square is equal to 4 lambda square, which says q square is equal to 2 lambda square. Now this says that q square is an even number. Now if q square is an even number, by the similar arguments we had earlier, q is an even number. Now if q is an even number, so it means that q is equal to 2 into some other integer, say mu, right? Now you have these two things. You have p is equal to 2 into something, and you have q is equal to 2 into something. It means that 2 divides p, and it means that 2 divides q. Now from these equations, this is say star, this is say double star. From star and double star, you have from star and double star, you have GCD of P and Q is at least 2, because you are saying that 2 divides P and 2 divides Q. Therefore GCD of P and Q is at least 2, which is a contradiction to 1, because we assumed that GCD of P and Q is 1. So it means that, what does it mean? It means that whatever you supposed is wrong, which it means that whatever we supposed is wrong, our supposition is wrong, and root 2 is an irrational number. Hence we proved whatever we tried to prove. Hence, hence proved.